Hi, 8th grade. All right, we are now going to be on lesson 1, session 3. And now I'm going to start assigning our homework with the name of the lesson session that we are on. That way it's easier for us to find. That way it's not just like the date, it's the actual lesson session. I think that'll just be helpful on my YouTube videos, and it'll be more helpful on Google Classroom. So we've been talking about rigid transformations. Remember, a rigid transformation means the shape stays the same, like it looks the same, but it rotates or it flips, or it actually can grow and shrink. If it grows and shrinks, that means that it did grow and shrink proportionally, so the shape still is the same, okay? Okay. But rigid transformations usually mean it doesn't change shape, so don't worry about that. If it's rigid, it stays the same. It just slides, moves, flips, okay? Let's go ahead and look at number 1. Lewis says that figure Y is a rotation of figure X. Explain Lewis's error. Okay, so that's kind of like what we were just talking about. If it was a true rotation, let me go ahead and just trace this to show you. This is what's so cool about doing it on my iPad, is I can like grab the shape now. Let me grab the shape. Woohoo, you. If this was a true rotation, now here's where I wish I could like twist this, but it means that I would be twisting it and rotating it around, and it would eventually land here, right? Let me see if I can resize it. Oh, that's pretty nice. Okay, well, I gotta be careful because I don't want to resize it, right? I want it to just like flip. So let me line it back up. Oops, come back here. Come back here, shape. Ah. No, the shape. Sorry, guys. I'm having issues. Okay, so it is the same shape, right? Same size, everything. So now let me resize it. I'm not going to resize it. Sorry, I'm not resizing it. I want to rotate. So did it... Ooh, try not to move, try not to move. I'm trying not to change the shape. Size. Ooh, okay. Did it rotate here? I mean, it did. It did rotate. But what's the big problem? What do you notice, size-wise? It's huge. Y somehow got huge, right? So what is Lewis's error? His error is a rigid transformation means that the shape doesn't change size. Sorry for my terrible handwriting. A rigid transformation means the shape doesn't change size. Okay, number 2. Why does figure B appear to be a reflection of figure A for each pair of these figures? Explain why or why not. Okay, so that dotted line is the line of reflection, okay? So remember, if something reflects, it's like the opposite. So these would have to be the exact same distance apart, which they are. Looks good. These would have to be the same distance apart. Ooh, it looks good. So is that first one a reflection? Yes. And I'm not going to explain why not, except for the fact that you know that if it reflects, each of the corresponding sides and angles would have to match up, right? Now let's look at this one. Is this a reflection? So this corresponding side or point is not this. And you know why I say that? Because look right next to it. It goes down and then a puzzle piece, right? This goes down and it goes in. So, oh, that's not okay. The corresponding side for this blue dot is actually right here. The corresponding side for this green dot is actually right here. Is this green dot the same distance from the reflection line as this green dot? No. Is this blue dot the same distance from the reflection line as this blue dot? No. This puzzle piece did not reflect across the line. It just slid across the line, correct? So is this a reflection? No. It is a translation. We know know what translations are. Translations are when you take a piece and you slide it. So we can say it's a slide, but that's what like fifth grade babies would say. It's not a slide, it's a translation, which means a slide. Number 3. Zara translates, or slides, figure P to make figure Q. If she translates figure Q 4 units to the right and makes figure R, will figure R be where will figure R be located? Explain your reasoning. Okay, so basically what we're doing is P is the original. She slid it to make Q, and now she wants to move. If she translates figure Q 4 units to the right, okay, where would it land? Let's go count. We just have to count, right? Each of these points, let's move it 4 spots to the right. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So if I were to slide Q back 4 points to the right, it would land exactly on P. It would land right back on figure P. And if you want a little visualization of that, let me do that for you. So let's say we start with P as our original. I'm going to trace P real quick. Ooh, sorry guys, my drawing is not well. P slid or translated over to make Q. Now if I move Q4 back over, it's just going to land right back on P, correct? That was kind of an easy question. Number 4. Akira draws some figures on grid paper. Here's her figures. Some of the figures are transformations of figure C. So see the blue shape? Figure C is the original, okay? Which figures appear to be rigid transformations of figure C? Okay, so I'm going to take my little device. I'm going to trace figure C real quick. The reason why is because I can pick it up and slide it all over the place. I can't rotate it very well without resizing it, which kind of stinks. Okay, so if I were to take figure C and slide it around, which of these other shapes would be a good slide of figure C? Oops, come here, little guy. Is that a good slide? No. 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 Yes. Okay. So G, it looks like part B is going to have us explain. So I'm not going to explain these things yet, but we know that G is something that was rigidly transformed. Okay. Now let's look at D, for example. D to me looks like it got reflected or flipped over a line of reflection. So if I were to take this little fella and flip him, I know this is so hard for me, I'm sorry, but if I were to flip him, come here, little guy. Oh, it's not gonna let me flip, darn it. Okay, well, if it would have let me flipped, I could flip it over the reflection line, and do you see how all the pieces would have lined up nicely? So D is a flip or a reflection. I don't think H doesn't have the same shape, as you can see. Like if I were to take C again, I mean, it looks like a rotation, right? But if I were to try to rotate that, come on, rotate without changing size, which is so hard. Ugh. And then grab it. Do you see how it's not even the same shape? So H is nothing. What about F? If I keep rotating it, could it be the same? Ooh, yay! Okay, F. Yes, we like F. But E, I can already tell. E is not the same shape. It's not the same size. E is trash. H is trash. Okay. Part B, explain why or how we can verify that each of those that we answered are actual rigid transformations. So here's where we're going to explain our answer. G was a slide or a translation. Yes, we're using our big words. G is a translation. D is a reflection. Because it flips. And F is a rotation. Okay, there we go. We explained them all. Part C says, identify the transformation Erica used to get each image of figure C. Wait, isn't that what we just did? Oh, okay. So I guess up here what we should have done is we should have like proved it. How do you prove it? Well, we could have said G is a slide because it doesn't rotate, it just slides. And D is a reflection because if you draw a line of reflection, you can make sure the corresponding sides are the same distance away from the line of reflection. Okay, there could have been a lot of writing that we could have done in there. We could have said F is a rotation because you can rotate it 180 degrees and slide it over to F. I mean, okay, yes, we could have explained everything very, very well. But I think we're going to skip that because I think you guys understand that. So we're just going to draw an arrow from here to here and say, there's my answer. Okay. Number 5. Perform a translation, a reflection, and a rotation of figure ABC. Use words and symbols to compare the size and the shape of figure ABC to your 3 images. Okay. So let's go ahead and start. I'm going to slide this little sucker. I'm going to slide him. How many do I want to move it? I want to move it 1, 2, 3, 4, 5. I'm going to move him 5. Okay, so I'm going to explain this because I'm actually going to use my words this time. So we're going to translate five units to the right. Okay, let's do it. Let's move each of these little pointy points 5 units to the right. Let's start with A. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to erase all my little markings, don't worry. Okay, now take my eraser. I'm going to get rid of all my little jumps because that way we can see it clearly without erasing my dots, of course. Okay, now I'm just going to connect it. That is a slide, and more specifically, it's a slide that happened by taking ABC and moving it 5 units to the right. Now I'm going to grab a blue, and blue is going to be my rotation. Actually, no, let's do reflection first, okay? We're going to reflect ABC over my line of reflection. My line of reflection is going to be 1 unit underneath C. So do you see how it's just 1 unit underneath C? Okay. So what you do when you reflect is you put your dots on your points and you say how many spaces is that point away from the line of reflection. So let's start with A. A is 1, 2, 3 spots away from the line of reflection. So our new A will be 1, 2, 3 spots away. So there's our new A. C is only 1, so our new C is going to be only 1. B is 1, 2, 3, so our new B will be 1, 2, 3. Now let's erase our marks. You guys can do this in your book too. Erase your marks because don't erase your line of reflection because that's kind of a good thing to see. But erase your jumps because their jumps are, make it a little harder to see. And then retrace it. Wonderful. Now do you see how it's a perfect reflection? Okay, so now I'm going to say over here, A, B, C is reflected over the line of reflection. Ooh, my word line got crazy there for a second. Lots of little squiggles. Okay, now we just have one more thing. We're going to rotate it. Now, my rotation, think of me when I was holding that stool in my classroom and I put it on one chair leg and I rotated it. Let's rotate this by point A being the pivot, okay? Let's rotate it 180 degrees. So 180 degrees is like a straight line. So I'm going to rotate it. Actually, let's just do 90 degrees, because if I do 90 degrees, that means point B will just go straight up to here, right? This would be point B. Point A would stay the same because that's our pivot. And then point C would be about right here. Okay, and then I'm going to erase my markings so that you guys can see this better. So what I did is I took A and I made that my pivot. Like in basketball, it's your foot that you're pivoting on. And I took it and I rotated it up, okay? So B went this way 90 degrees, C went this way 90 degrees, and A stayed the same. Okay, so for my explanation, I'm going to say I rotated around the center of A. What that means is I'm saying that A was my pivot, right? A was how I moved it and I pivoted it. All right, guys. So that is the end of Lesson 1, Session 3. And as you can see, there is not a green worksheet for tomorrow. So what that means is what we'll be doing tomorrow instead is reviewing for a quiz. We will have a quiz over the first 3 sections. All right, so think of your questions now so that when we get together, we can have questions be answered. All right, bye, guys.